Hey everybody, I hope you're all doing good. So today's lesson is going to be on determining the equation of trigonometric functions. Now, this is kind of the third lesson in this new part of trig where we're talking about the equations. A reminder from the last two lessons, we have dealt with what this whole thing looks like. So this is taking y equals a sine of b x minus c plus d, and we have these parameters where we've talked about them now as transformations, but then we've also talked about them inside trig. We know that A is your amplitude, and that's the distance from your midline up to your max, or from your midline down to your min. We know that B is related to the period, where B is 2 pi divided by your period, or your period is 2 pi divided by B, depending on which one you have. C is going to be your horizontal translation, left or right, but in trig we often refer to that as a phase shift. And D is your vertical displacement, which is your vertical translation, either up or down. So in the last two lessons, what we've done is we've taken a look at actually trying to draw those graphs. This third lesson, we're actually now going to go backwards. We're going to give you the graph and you have to try and come up with the equation. So if you take a look at your book, and we'll get started here. So when determining the equation of a sinusoidal function from a graph, the very first thing we want to do is we want to find that midline. Remember that the midline is your d value. So if I look at my d value, the d value is going to be the average or the halfway point between the minimum and the maximum. So I see a minimum here of 1 and I see a maximum here of 5. The halfway point there is going to be 3. So what I would do right away is just draw that in. Remember to draw it in as a dotted line because it's not actually part of the function. Okay, but now that also tells me that our d value is 3, so we can write d equals 3 as we're trying to establish the parameters that we've got. Okay, the second thing we want to do is find the amplitude. Now, the amplitude is going to go from the midline up to the max or from the midline down to the min. So if I look at that, there are formulas for this, but I think it's easier just to count them. If we're going to look at that, we just from that midline, we just go up 2 to the max, or from that midline, we go down 2 to the min. So that tells me that the amplitude is 2. So in your notes, as you're establishing the parameters, you just want to write A equals 2. Okay, then the third thing we want to do is find your period. Now, a reminder that the period is the horizontal distance from one particular start of the graph to where that exact start happens again. Now, there's a couple different ways you can do that. You can look at it from minimum to minimum. You can look at it from maximum to maximum if you have that. We don't quite have that on this drawing. Or you could look at it from your midline intercept over to your second midline intercept. That's where the graph will start again. You don't want to go from midline to the very next midline. If you look at that, that's only half of your period. So you just want to be careful with that. For this one, I'm going to go from your minimum over to your other minimum because I can see that really easy. So I'm going to look at the period from there to there. And so I look at that and I say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, I did that wrong. Sorry. 1, 2, 3, 4, 5, 6, 7, 8 full tick marks there. And if I look at every tick mark is half pi. So if I'm going 8 tick marks, that's essentially 4 pi. I have a period here of 4 pi. Okay, so now the next thing I want to do with that is I want to figure out the b value. Now the relationship between your period and your b value is that b will equal 2 pi divided by that new period. So if I go 2 pi divided by my new period, which is 4 pi, that's going to give me a b value of 1/2. So then I can write that over to the side. I have a b value of 1/2. Okay, so I've got A, I've got B, and I've got D. Notice that I skipped C. The reason I skipped C is because it depends on which equation you actually want to determine. Every picture that you see here, that's a sinusoidal wave, pardon me, there's an infinite amount of equations that I can write. I could write this graph as a sine graph. I could write it as a cosine graph. I could write it as a reflective sine. That means a negative sign. Or I could write it as a reflective cos. The A, the B, and the D are never going to change as I do all of those equations. What will change is the C value or the phase shift. Okay, so we're just going to take a quick look at trying to find those pictures. So just a quick reminder, based on what we've done in some previous lessons as well, a cosine graph is always going to begin at a maximum and then heading down. So that's, oh, sorry, I didn't mean to do that. Let's go back. Okay, a cosine graph starts at a maximum and then always heads down. A sine graph is always going to start at a midline and heads up. So we've actually, on this diagram, we've marked where the starting C value would be. So sine would start here, which means that distance there is your phase shift, because if there hadn't been a phase shift, that would have had to have started on the y-axis right here. So we know we've moved that many units to the right. Whereas cosine, we know we've moved that many units to the right, because if we were going to do a cosine with no phase shift, that green dot here would have had to have been over on the y-axis if there wasn't a phase shift. Then a reflective cosine starts at the minimum, so we could start right here, minimum, and goes up. And a reflective sine graph would start at the midline going down. So here's an example of a start for a reflective sine graph. Okay. Okay, so just a couple reminders before we actually get into an example. As you do these things, you're always going to create your function in factored form. So just remember, like every other transformational equation we've done, you want to have that b value outside of another set of brackets where you have the x minus c. Okay, and that's the same for sine or cosine. Here are a couple formulas that you want to, if you're a formula-loving person, you want to think about. Again, this A and D, I'm not a big fan of actually using the formulas. I'd rather you draw yourself a little picture and then just count out. But that's how you find A and D from a formula perspective. And then the relationship between your period and B has been written over here. Your period is 2 pi divided by B, or B is 2 pi divided by your period. So let's try an example together. What I want to encourage you to do a couple of times through this lesson too, I'm not going to wait for you to write stuff down because that would make the lesson too large a file. So I'm just going to say this would be a good time to pause every now and then and try and write some stuff down. So I'd like you to pause and see if you can write out the amplitude, the period, and the vertical displacement. Just deal with those guys first. Okay, so when I take a look at this, I see, okay, here right away, my eyes always go right to that midline. I know I have a midline here of -1. So that's going to be my vertical displacement. My vertical displacement will be -1, and I know that the d value is -1. From there, if you can see my mouse here for a sec, I'm going to count up 1, 2, 3 to get to the maximum. And if I went back to -1, I'd go down 1, 2, 3 to get to the minimum. So I know that my amplitude is going to be -3. Then I have to deal with the period. I happen to see a period right here, right away. From here to here, I'm going to just use those minimum points. So if I was to count that, I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I have 12 tick marks. Now, I can't say 12 tick marks, but what I want to do is I want to establish what is a tick mark. So a tick mark is going to be, I count from 0 to pi and figure out how much one tick mark is worth. So up here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that it's 12 tick marks to pi. That tells me every tick mark is actually 1 over 12. It also tells me then that this period is pi. So I know that 1 tick is pi over 12, and I now have established that my amplitude is 3, my period is pi, and my vertical displacement is -1. So a reminder that the amplitude is going to be your A value. Your period helps you figure out the B value. Remember that it will be 2 pi divided by your period. So 2 pi divided by pi, that means I'm going to have a B value of 2. And I've got a D value of -1. So now the only difference is going to be how I get the phase shift for the sine equation, the cosine equation, the reflective sine, and the reflective cos. So we're going to go through each one of these and just try and find a picture. So let's deal with the sine equation first. You're looking for a picture on this graph where you start at a midline. So you're starting at that -1 line, and you're heading up, okay? So try and find that picture on your paper. And the picture I've shown you is right here. Now, you might say, hey, how come I didn't start right here? Or how come I didn't start right here? And all of those are great. All of those would be sine graphs with slightly bigger phase shifts. And all of those would technically be correct. When we draw these equations, though, we always want what we call a minimum phase shift. So we want the starting point that's as close to the y-axis as possible. That way, we'll have the smallest c value that we possibly can make. Okay, so for this guy, if there had been no phase shift, that would have started right on the y-axis. So I've shifted that 1, 2, 3, 4 units left. Now remember, every tick is pi over 12. So that's like 4 pi over 12 to the left. Now we wouldn't write 4 pi over 12, though. We'll reduce that. So 4 pi over 12 reduces to pi over 3, and that's where this equation comes from. Then we take a look at a cosine equation. Well, a cosine equation starts at a maximum and heads down. So I want you to find on your graph the closest to the y-axis where you would start on a maximum and head down. So here's the picture I'm hoping that you found. If there was no phase shift, that would have started on the y-axis. So I've shifted 1 tick mark over to the left. A reminder that 1 tick is pi over 12. So that means I have a c value here of negative pi over 12. When it goes into the equation, it will be x minus negative pi over 12, just like every transformation equation that you've done. And so that's going to end up being x plus pi over 12. For a reflective sine, I'm now looking for a spot where I start on the midline and I head down. So starting on the midline, heading down, this is your closest picture to the y-axis. I see that I've gone 2 tick marks to the right for my c value. So in my equation, that's going to end up being x minus 2 pi over 12, but we'll reduce that to pi over 6. So notice again, in all of these equations, the a value staying the same, the b value staying the same, and the d value is staying the same. The only difference is the c value, and if it's reflective, I got to make sure that I put a negative on that equation as well. Then for the reflective cosine, we start at a minimum and we head up. So when we look at that, here's the picture I showed you. So we've got 1, 2, 3, 4, 5 tick marks over to the right. Just to compare, because some of you may have looked at this, we would go 1, 2, 3, 4, 5, 6, 7 to the left. So this guy is the closer start. Okay, so 5 tick marks to the right, that'd be 5 over 12, and the reflective cosine equation would look like that. Okay, so if you had a graphing calculator, you could put all of this in like y1, y2, y3, y4, all 4 of those equations. What you'll notice is it's the same line every time, and it would represent this picture that you see here. Now, the last part of that says verify one of the equations with the given point. So you have a very obvious point given to you here with that big dot, so we're going to use that guy. And then just pick one of the equations. A reminder, when you verify something, you want to plug in the x and y value into the equation. And then you want to make sure you're never crossing the equal sign. So leave the left side as it is, leave the right side as it is, just work on the left side, just work on the right side, and make sure that they come to equal the same thing. So this is what your verification will look like. I'm going to choose that guy, the reflective cos, just for fun. Doesn't really matter. And so I plugged in the pi over 6 comma negative 1. That was the point that we saw there. Remember, it was 2 tick marks over, so that'd be 2 pi over 12, and then I just reduced that to pi over 6. So now I'm going to have to do some work on this side. Pi over 6 is, as I just said, 2 pi over 12. So I'm looking at that and going 2 pi over 12 minus 5 pi over 12. Oh, sorry. Okay, sorry, there was a slight glitch there. So pi over 6 is like 2 pi over 12. 2 pi over 12 minus 5 pi over 12 would give you negative 3 pi over 12, and that reduces to negative pi over 4. Now, you can look at, let's multiply the 2 now. So we've got 2 times negative pi over 4. That's going to give me negative pi over 2. Negative pi over 2, a reminder on your unit circle, this here would be negative pi over 2. And so the cos value of negative pi over 2 would be 0. So cos of all of this is 0, which is why I end up with negative 3 times 0 minus 1. Negative 3 times 0 is 0. I end up with a proper verification that says negative 1 equals negative 1. Okay, good. The second example, what I would encourage you to do is pause and try and fill in as much as you can of this, and then just put me back when you're ready to talk. So if I look at this, the my d value, again, is going to be right at negative 1 here. If I see negative 1, I'm going to go up 1, 2, 3, and I'm going to go down 1, 2, 3. So I have an amplitude of 3 and a vertical displacement of negative 1. The period on this guy is a little trickier. Let's first establish what a tick mark's worth. I've got 1, 2, 3, 4, 5, 6 tick marks to pi over 2. That means it's 12 tick marks to pi. So again, in this one, every tick is going to be worth pi over 12. For my period then, I'm essentially not really given an obvious full period here, but I am given an obvious half. If I go from a min to a max, that's half of a period. So we're going to count, and I'm going to hopefully not get dizzy here as I do this with my mouse. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I've got 24 tick marks is half a period. So that means 48 tick marks would be a full period. Well, 48 pi over 12, that's really just saying 4 pi. So my period here is 4 pi. So now I know my A value. My A value is 3. My B value is going to be 2 pi over 4 pi, so that'll be a half. And my D value is negative 1. So now I'm ready to build the equations. When I go to build the equations, I just have to think about where each guy is starting. So I know that sine is going to start on the midline and head up. So if you can see my mouse circling there, that's going to be where sine is. Cosine is going to start on the maximum and head down. So that point there is going to be the phase shift for cosine. The reflective sine would start at the minimum going down. So it's right about there. And the reflective cos would start at the minimum going up. Okay, so see if you can draw those equations. Just pause the video for a sec. You guys try them. And here is your answers. See how you did. Okay, so 4 more examples that we're going to go through together. And again, I'm just going to kind of go through the same way. We're going to establish what your parameters are. Oh, sorry, I forgot to verify. I just get so excited. Okay, so we're going to verify using this guy this time, the sine equation. And the point I chose was the one that was kind of shown to you there. So that's 2 pi over 3 comma 2. Plug that in. 2 pi over 3 plus pi over 3. Just remember your order of operations. You got to do what's inside the brackets first. That would be 3 pi over 3, which is just pi. Pi times a half is half pi. So I'm looking at sine of half pi. Sine of half pi is this way. Remember that sine is your y value, so that would be a 1. So sine of pi over 2 is 1. I'm looking at 3 times 1 minus 1, which means 2 equals 2. So that's a proper verification of that guy as well. Okay, so determine the 4 possible equations for the following sinusoidal graphs or descriptions. So we're looking for a sine equation, a reflective sine equation, cosine, reflective cosine. Those are the 4 that we're going to try. Now, as I go through this slide, I'm going to establish what your parameters are, and then I'll show you all the equations. So pause as you need to, because I want you guys to try this on your own as well. So if we're looking at the first guy here, I have a d value of negative, sorry, my picture of myself was in the way. I've got 1 for a d value here, and for an a value, 1, 2, 3, 4, 1, 2, 3, 4. So I have a d value of 1, I have an a value of 4. I want to know how many ticks it is to pi. So I'm going to go 1, 2, 3, 4, 5, 6 ticks to pi. That means every tick is pi over 6. So now I'm going to count from my my min to my min. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a period of 2 pi. If I have a period of 2 pi, my b value will be 2 pi over 2 pi. So that'd be 1. So I have an a value of 2, a b value of 1, a d value of 1. Now try and do the equations. You can pause me for a sec. This is way better than real life because you can pause me anytime you want. I can just shut up anytime you want. You just press the pause button. And here are your 4 equations. The sine equation actually had no phase shift because it started on the midline and the y-axis heading up. The cosine equation, I went right pi over 2. For the reflective sine equation, it doesn't matter which one you do because they're equal distance from each other. So you could have either said plus pi or minus pi. It doesn't matter. You don't have to say plus or minus. Like you don't have to say both. I'm just saying either one I'd mark correct. And then for the reflective cos, I ended up going to the left pi over 2. All right, for the next guy, oh, we're going to verify, sorry. So the point, I'm going to use the sine graph with no phase shift. And the point I chose was 2 pi comma 1. Sine of 2 pi is 0. So I end up with 2 times 0. Very quick verification to say 1 equals 1. For the second guy, get your A, B, and D. This is them. I'm assuming you paused me. Now get your equations. And this is them. So again, your D value is right in the middle here. You had a -2. The A value from that -2, you're going up 1 to your max or down 1 to your min. Your B value, you had to figure out the period. So this is going to be hard to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm 12 ticks to pi. So every tick is pi over 12. And then I see, well, actually, I can see very easily here that my period is pi because I can just see that minimum to minimum there right at the pi mark. So my period's pi. My d value then would be 2 pi divided by pi, which is where I'm getting the 2. And then I had a shift of pi over 4 to the right for sine, a shift of pi over 2 to the right for cosine. So there's where the cosine was. Here's where the sine was if you lost that. To the left pi over 4 for negative sine right there. And no phase shift for negative cos because that started right at the bottom. All right, 2 more examples to go. In the next one, oh, sorry, I forgot to verify. So I used the one with no phase shift just to make my life easy. And I used the point 0, -3. That was one. This one, there was none that was marked for you, but I felt that was an obvious one to use. 2 times 0 is 0. The cos of 0 is 1. Remember that 0 is right here, and cos would be your x value. So cos of 0 is 1. I'm looking at -1 minus 2, and that's -3. So there's my verification. Okay, second last example together. You try and find A, B, and D for me. This is what you would have gotten. A is 3. D is -1. -1 is my middle point there, and then from there I'm going up 1, 2, 3. The B value is a half. If I look here, I'm going from -2 pi to 2 pi. So I have a period of 4 pi. A period of 4 pi would give me a B value of 2 pi over 4 pi, which is where I'm getting the 1/2. Okay, try and write your equations. And here they are. And then in the last example gives you no picture. Now, one of the best things you can probably do is to actually draw the picture. Oh, I forgot my verification, sorry. So I picked the point, see, I mess up as much in video as I do in person. So I picked the point 0, 2. So plug that in, I got 1/2 times 0. So again, this is cos of 0. Cos of 0 is 1, so I'm looking at 3 minus 1, and I get a verification of 2 equals 2. Sorry about that. Okay, and then in the last example, I've taken out, you have determined the C value there. I actually want to see if you can do all 4, because I thought that'd be more fun. A sinusoidal function has a maximum at pi over 6, 2, and its next consecutive minimum at 3 pi over 6. So what I would do right away is just draw a picture of that. So I have a maximum. I have a maximum at pi over 6, 2. So I'm just going to go 1, 2, 3, 4, 5, 6, and call that pi. So pi over 6, 2. I'm right there. And then the minimum is at 3 pi over 6, -4. So 1, 2, 3 pi over 6, -4. Well, I know that the midline has to happen exactly halfway. So I know the midline is going to have to happen at 2 pi over 6, which would reduce to pi over 3. But for now, I'll just call it 2 pi over 6. And then it has to be the average of these two guys. So I know that my A value, sorry, I started with the D value. The D value is the average, which is 2 plus -4 divided by 2. So I get a D value of -1. So I know right away now that my D value of -1 could be drawn in. And now I know what that point will be. And I might need that point in a minute. So my graph is going to look something like this right now. And that's enough to try and get the rest of the information that I need. So then I have a period. Now, the reason I multiplied that by 2 is because going from that max to that min is only half of a period. So I subtracted 3 pi over 6 minus pi over 6. That gave me half the period. Then I multiplied it by 2 to get the full period. Now that I know the period, I can get B by going 2 pi divided by my period. Remember, when you're multiplying fractions, you just, when you're dividing fractions, you multiply by the reciprocal. So that is why B ends up being 3. Okay? Now, using that information and thinking about this picture, I want you to try and get the 4 equations. You can pause me for a sec. Sorry, I don't think I told you A was 3, but A is 3. We could have just counted that up or down. And here are your 4 equations. Okay, so I hope the video has been helpful. As always, if you do have any questions, feel free to email me, and we will chat soon. Take care of yourself, guys. Oh, and your homework, of course. Oh, my dear. I forgot your verification. So I picked the point, there's just the second one I was given. So when I do that multiplication, I end up with 3 pi over 2. Then I have -3 minus 1, and -3 minus 1 is -4. Okay, so your homework is on this lesson is 198 to 207. And hopefully, as I said, this is helpful. Please email me if you have any questions, and we'll see you on the next lesson. Okay, take care, guys.